everybody. Hi, everybody. This is Mrs. Gallagher, and this first lecture session is on the introduction to chemistry. The best place to start is just knowing what chemistry is and what it entails. So if we look at this, chemistry is just a physical science, and it goes through the study of what matter is made of, the structure of matter, and the properties that it contains and how it can change. There are many different branches of chemistry. We'll, um, we'll look at a little bit of organic, inorganic, physical, analytical, and biochem in this class and get examples of how those are being used. So if we look at the branches, the organic, this is the part where we'll look at components that are made with carbon. And inorganic chemistry is going to look then at the substances that don't contain carbon. Then physical and analytical. Physical looks at, again, those changes that the matter can undergo and how much energy you need to get this to happen or how much is going to be given off. Analytical is when you are actually looking at what the substance is made of. So we're more concerned with, what is water? How many hydrogen to every oxygen are there? H2O. Biochem, we see this all over. This is looking at anything bio in life, and that's involving chemistry. So this could be anything from your nutrition, from why do your muscles contract and release, why do certain chemicals enhance the growth of living things like corn crops or flowers versus why do some things retard their growth or slow them. In all of the different branches of chemistry, they're going to go through just the different styles of research. Some of the research is just going to be because we need the knowledge of what we're looking at. So we do some background knowledge to see what people have already done, so we're not reinventing the wheel. And then we do some applied research that will be purposely to solve a problem, not just for our knowledge, but to actually help something be more efficient. Then with these two types, basically, once you have more knowledge, it's going to end up going into a technological development where we are going to be looking at what things will help us solve that problem, what things can help us do things more efficiently. So chemistry is all of this. It's not just know what the periodic table is, know what the chemical symbols are. That's just the beginning, and we want that knowledge so that we can take it further and be able to solve problems and encourage and promote more technological advances that will help things become more efficient as we gain more knowledge. To do this, we go through, which is basically just our thought process. We forever have been calling it the scientific method. Now it's been called the design process. It's the same thing. It's that mindset that you have when you're going in and I just finished a water bottle and I'm going to figure out where I should put it. I want to recycle it. I don't want to throw it away. So I walk into a room and I look around. I see a couple cans that seem like they could possibly be, disposal centers. So I'm going to go and I'm going to check out what they are. So I have a problem. I need to recycle my bottle. And so then I'm going to gather some background knowledge. I'm looking around and seeing what's there. And then I'm going to do some tests. I'm going to go up to those cans and I'm going to look in them and see what's in it. If I walk up and both cans are filled with food and trash, then I know I don't want to put my bottle in there if I'm looking to recycle it. So then I'm going to retest. I'm going to look for different options, and then I'm going to go up to them and I'm going to look in it and I'm going to draw a conclusion, either that I have found it and I can go ahead with what I want to do and recycle it, or I'm going to come up with a conclusion that there's not a recycling session, station in this building. And so I either have the option of hanging on to it and recycling it somewhere else, or I can dispose of it in the trash. So let's look at the design process. Basically, all we're doing is we're putting it down on paper to how we're thinking and walking through the process, so that if somebody else wants to go back through it and see how we came up with our conclusions, they can. So here are all of our steps. We said define the problem, do your background research, specify what requirements there are going to be, create alternative solutions, and then choose the best one from all of the things that you've come up with, develop that one, make a prototype, and then test and redesign that. And once you have your final project, then you can communicate the results, which could put you right back into redesigning it and then building another prototype, and or maybe somebody else had other knowledge. So this is a very cyclical process. It's not go through the steps and you're done. It is to continuously cycle back through to let or to allow for improvements continuously. So if we look at defining the problem, basically all research is going to start with some type of question. What is the problem? Or what is the need? Who has the problem or this need? Why is it important to solve it? And what are our restraints that we need to stay within when we are trying to solve it? So after we've defined the problem, then we want to go through and do our background research. Our background research is we're going to look for people who've already tried to do some of this and um, see what they've done and what's worked and what hasn't worked. That way, we're not reinventing the wheel. We're looking where their mistakes didn't work, and now we're not going to make those same mistakes. They've done them, so let's just take their knowledge and start from there. And that way we don't have to try the things that other people have already tried. Whenever we're looking for this background information, there are some main places to start looking. And one is if you look at who is using this or who has the need for this, so our consumers and stuff, then we're going to kind of be able to see what the need really is and get a true definition in our mind of what we're trying to create. Then, as I said, look at things that have already been done so that we don't make those same mistakes. For every project, you're going to have requirements, and those are going to be a multitude of things. But a few things that you have to keep in mind um, are just simply, what is it? If you're actually producing something, then what are the measurements you have to stay within? Does it have to be a certain size so that if it's too small or too large, it won't work? It's made for a specific place. Then you also have to think about, well, what do I have available? What type of materials am I going to be able to use? Because materials themselves are going to have limitations, such as how much heat they can hold or their flexibility and being able to maneuver with them. So those are things that I'm going to have to consider when I'm thinking about what I'm going to develop. I'm also going to have to think about, what equipment do I have? Do I, do I have very minimum equipment? Can I use anything? What's there? Do I have a balance? Do I have glassware? Or, do I have something that measures accurately? What is it that I have to work with? Then our timeline. How fast do they need this? You know, we have to work out from the beginning what our plan is, to see if I only have a week to develop something, then I'm going to need to spend a lot of time up front going through and testing all my different things, so that towards the end I know I have enough time to refine and redesign as I encounter problems that I didn't even imagine at the beginning. One of the important things that, uh, especially in a classroom when we're learning about how we would design something, that gets kind of thrown out the window, is the budget. But every project that you work on, whoever you are working for, is going to have a budget. What do you have to stay within? That's going to limit then the materials that you can use, because different metals are going to cost different amounts. So how much do I have allotted for this project to be able to spend? And that may tell me whether I need to look at maybe recycling some things that I already have and seeing how I can use those to do the job, instead of starting from scratch and, building something that, um, all the components of it are just brand new. One thing that can help when I'm trying to stay on budget is, when you were doing your background research, I can go back to those that, were successful developments. Maybe they weren't the most efficient, but I can go back to those and look at, what did they use, and is there something that I can use that would be more effective in this area, or did that do the job that I needed it done and it was cost effective? So if I use that one portion, are there ways to make it more efficient by adding different materials to it? Maybe things that they didn't think of before. But again, just like we said back on background research, not to reinvent the wheel. Look at what they've done and what characteristics worked well. You might be able to take three different designs and pull parts from them that you're like, those are really good ideas. So let me take all of those and incorporate those in my development. Whenever you start coming up with a way to solve your problem or your need, you need to make sure that you have an open mind, and if you're working with a team, take in everybody's aspect. We have a tendency to think, okay, this is how I want to do it, so this is the way that it needs to be done. There are multiple ways to solve many problems, so take all of those and look at all of them. You never know when there's going to be just one little idea from somebody's that will make your idea even better. And you can, just like looking at the background and pulling things together, you can take all of your ideas and pull the best parts and create something that would be even better than one of you could come up with. Out of all of your ideas, as I said, then you're going to pick which one is best. You're not going to develop all of those. Again, remember, everything works on a budget. So we cannot develop a multitude of prototypes and say, okay, pick the one that you like the best. It's not a contest, it's a team. And you're trying to create something that's going to help your consumer the most. So look at all of them, go through what are the requirements, which ones, are there some of them that meet all of them, but maybe kind of stretches this one a little. Well, if that one doesn't work, then that's not the best solution. Let's move that one, throw it out, move it over to the side. We're looking at the ones that stay within all of our requirements and are successful at the end of solving our problem or fulfilling our need. Once we've narrowed it down to our best design, then we're going to develop this. And to develop it, it's going to, include lots of refinements and improvements of going through that design. And that's just going to continue through this whole process is um, refining our development, improving upon it. Because I said, everything is going to be a problem solving process. We have to find the best way to do it. So it doesn't mean once we've come up with an idea, that's it. We're going to develop it, and if it works, it works. If it doesn't, it doesn't. We want to make sure that having the best product, it is truly the best product that we could develop. Once we've developed it, we've seen any problems, then you're actually going to build a prototype. And prototypes are literally a working version of your solution. Just usually they're made with different materials because of cost. Again, you're trying just to show kind of a cheap version and see if there's any problems that that prototype runs into. Then it can actually be used, and that's going to give us problem solving opportunity prior to footing the big bill with the final project. So once you have that prototype, we'll test it, we'll redesign it, we keep improving upon it uh, through this whole thing until we finally come to what we think is our best product that we can make, or our best solution or answer to a question that we can come up with. And that is what we're going to communicate. That's what we're going to um, tell our consumer or the person who has the problem or needs an answer to an issue. That's what we're going to communicate. And we can communicate these, they might be verbal, they might be presentations, they could be written reports. And usually when you work with companies, it encompasses all of that information. You have to remember when you go through this design process or the scientific method that this is just your thought process. And it is always going to be cyclical. You are going to continually cycle through it. You're going to start, you're going to reach an answer that's going to bring up more questions, and you're going to go back through it. So just like your ideas on many things in life, they're not going to end and think, nope, that's just the way it is. You're always going to evaluate each situation and see how your mind can develop and understand it the best way possible.